So without further ado, first one, we got 3x plus 5y is equal to negative 10. That's in standard form, but it's still a linear equation because x has a power of 1. So we'll say that again. It's still a linear equation because x has a power of 1. And then you have y equals x plus 6. Currently, do we have something that's solved for x equals or y equals?
Yeah.
Yes. So don't try and solve the first one for x equals or y equals. You already have 1. You only need 1 to be in variable equals format. Okay, so you got y equals x plus 6. So I'm going to circle the x plus 6. It's telling me y is equal to that. We're trying to get an equation we can actually solve. I can't solve either of these right now. What should I do with that x plus 6? Here, what should I do with it? Hold on, I have a few people talking. Say it again.
Plug it into y on the top equation.
Yeah, I'm told that y is equal to x plus 6, so now I'm going to substitute x plus 6 for y. So I'm going to circle the x plus 6, I'm going to draw an arrow to where it's going to go. Now you're going to rewrite that top equation, but instead of putting y, you're going to put x plus 6 in parentheses. That's important. So 3x plus 5. It's supposed to be 5y, but I know that y is equal to x plus 6. These equations work together, so we're going to put them together in one equation. Looking at that now is that an equation you can solve? Yeah, because it's only got one variable. It's got x, and you can solve for x. So go ahead and solve for x. In case you forgot, make sure you distribute, combine like terms, and then solve. 5x plus 30 is equal to negative 10. So that's 8x plus 30. Luke term. And then keep solving from there. So it'd be x equals negative 5. Okay, we got x equals 5, but you have a system of equations, which means you need two variables. So what should I do with that x equals 5 now? Catherine? Right. It makes a whole lot more sense to plug it back into x plus 6 because that one is a lot simpler. It also is already in y equals format. So we're going to now take x equals 5, x equals negative 5, and replace x. So y is equal to negative 5 plus 6 because I'm using this equation. So y is equal to 1. Write your final answer as a point. Negative 5, 1, x, y. Looking at this right now, would you please tell your neighbor what's the problem? They are. They're both in standard form, which means that there's nothing that's x equals or y equals right now. Which means you have to, in order to use substitution, you got to make one of these in x equals or y equals form. Here's what you need to ask yourself. Please listen very carefully right now. You need to ask yourself which of these equations will be easier to solve and which variable is going to be easier to solve for. If y is more difficult to solve for, if it takes more steps, then don't do it. If solving for x gets you fractions or decimals, then don't do it. You want to make this as pretty as possible. So we right now have equation 1 and equation 2. Tell your neighbor, which one do you think will be prettier when you solve it? 2. X does not have a coefficient, which means you wouldn't have to divide. That'd be nice. So we are going to solve for 2, but should I solve, if I'm solving x minus 7y is equal to negative 1, should I solve for x or should I solve for y? It doesn't matter, but there's probably a better choice. Okay, let's if we could actually do this, let's just solve for y and see what happens. If you don't want to actually do it on your paper, so you don't have to erase it, that's fine, but watch me. I'm going to solve this equation on the bottom for y. So I would have to subtract x, which would get me negative 7y is equal to negative 1 minus x. Then I divide by negative 7, and I get 1/7 plus 1/7 x. Do you like that?
No.
Neither do I. Don't do it. Don't do that to yourself. Look at it again. Why is x the better option? Besides the fact that y is awful to solve for and you get fractions. Not that fractions are completely terrible, but you don't need them in this one. Why is solving for x the better option? Emma?
Because there's less steps and you get better numbers to work with.
Yeah, what do I have to do if I want to solve this bottom equation for x?
Add 7y.
Add 7y, that's it. Watch. Rewrite it. X is equal to negative 1 plus 7y. Wow, how beautiful. No fractions, no decimals. We didn't have to divide. It was one step. All I had to do was add the 7y because it was negative. And that's it. So what I'm going to do from here is I'm actually going to rewrite my system just to make sure I don't mess it up. So the other equation was 8x minus 3y is equal to negative 8. I don't want to forget about that. And I'm going to draw this little bracket thing to represent that's a system. Now that you actually have an equation solved for a variable, you can substitute and solve. So I take my negative 1 plus 7y. Keely, where do I put it?
In the x's place.
Right there. So write it out. So it'd be 8, but instead of x, it's going to be negative 1 plus 7y. And then the rest is the same. So on this one, you are going to solve for y first, and then go back and probably use this equation, x equals negative 1 plus 7y, to get your x. Go ahead and solve the system. 42y. Did I do that right? Oh my God. That's not right. Just kidding. 56, I mean. Don't you get 0? Okay. Y equals 0. Luke, what do I do after that?
You plug y equals 0 into whichever equation.
Which one do you think would be the easiest? Which equation is best? We actually have 3 options. The 2 original, and then the one we actually solved.
The first one. The one that's already solved.
There you go. The one that's already solved for x is going to be a lot easier. You can use that one. I know it's not an original, but as long as you solved it correctly, it should work. Negative 1 plus 7 times 0 would just be negative 1. Write your final answer as a point. Negative 1 comma 0 is your final answer. Be careful. You solved for y first. That is not what goes first in the point. It goes in the y spot, which might be stating the obvious, but be careful. If you make a good decision, then you would make the decision that the bottom one is easier to solve for. So I would say I'm going to solve for this bottom one, so I'm going to solve it for x, because then I don't have to divide or anything. So I would subtract 6y, and I'm going to rewrite my system. The first equation would be x is equal to 0 minus 6y. I don't need the 0, so just negative 6y. And then the other equation would be your original, because we haven't solved it. Replace, and let's talk about our dilemma here. So if you go ahead and simplify that, you get 18y minus 18y is equal to negative 5. 18y minus 18y, you should just write 0, not 0y. They cancel each other out, so just write 0 is equal to negative 5. Is that a true statement?
No.
No. Put a big slash. What do we say? If we're solving an equation and we end up with something that's false, what do we say, DJ?
No solution.
No solutions.
That means that they're parallel lines.
That does mean that they're parallel lines. And you could actually solve these equations for y, and you should get that they turn out to be, what they have the same slope, different y-intercepts.
It'd be x equals or I.
Okay, did you guys solve for the first one?
Yes.
So x is equal to 2 minus 2y, and then write your original for the other one. What ends up happening?
6 minus 6y plus 6y.
So you end up with, if you simplify that, you get 6 is equal to 6. So, Pierre, what should I say? Infinite solutions. So, Southwick, what kind of lines are these?
These are the same equations.
Yeah, the exact same. They're going to be, we call overlapping, right? So you're going to say infinite solutions. Yes, Pierre?